Hi guys, welcome back to my channel. I hope you are all doing well. So after so long I have come to my channel, and today in this session I will discuss about some problems on functions of one function and other functions. So let's proceed. We will discuss the problems from question number 4. So here the question is, determine whether the following functions are onto or not. Determine whether the following functions are onto or not. The first question is, a function f from n to n where f of x equal 4x. So to show onto of a function, there is a point to remember. We need to check, or sometimes we need to show range of the function equal to codomain of the function. Now in this problem we take y equal f of x. As defined above, y will be equal 4x. Now we express x in terms of y. Then x equal y by 4. Now for any y belongs to n, y by 4 does not belong to a natural number all the time. But in the question here, domain is n and codomain is n. That means both are set of natural numbers. But here we could not find the range as the natural number. Therefore, this function f is not onto. Hence, this is done. The question number 2, a function f from set of rational numbers q minus 3 to q, defined as f of x equal twice x plus 3 divided by x minus 3. We have to check whether this function f is onto or not. Let y equal f of x. According to this question, y will be equal to twice x plus 3 divided by x minus 3. We cross multiply it, then it will be xy minus 3y equal twice x plus 3. Now since we have to show x in terms of y, we take this twice x in the left side, xy minus twice x, and thrice y will be plus 3y plus 3. Here we take x as common, then x into y minus 2 equal 3y plus 3. x will be equal to 3y plus 3 divided by y minus 2. Now this x equal to 3y plus 3 divided by y minus 2 will be defined, will exist if y will not be equal to 2. Because whenever we take y equal to, then we will get 3 into 2 plus 3 divided by 2 minus 2. And 2 minus 2 is equal to 0. That means this will be not defined. Therefore, we have to take y not equal to 2. Therefore, here y belongs to q minus 2. But in the question, this is domain, q minus 3 is domain and this is codomain. But here range is q minus 2. Since codomain and range are not equal, therefore this function f is also not onto. Since this is not equal to q, therefore this function f is not onto. Right? So the next question is question number 3. Question number 3. A function f from set of real numbers to close interval minus 1 to 1 such that f of x equal sin x. So we have to check whether this function f onto or not. We know that range of a sine function is nothing but the closed interval minus 1, 1, and domain of sine inverse, which is an inverse trigonometric function, and domain of this sine inverse is minus 1, 1. Now, product solution, let us take y equal f of x. F of x is nothing but sin x. Then x will be sine inverse of y. Since the domain of this sine inverse is minus 1, 1, therefore this x will be exist in the interval minus 1, 1. And here in the question, domain is R and codomain is minus 1 to 1. Since range and codomain are equal, since range equal codomain, therefore this function f of x equals sin x is onto function. This is done. So you can see here, domain of a sine, range of a sine function is closed interval minus 1 to 1, and domain of a sine inverse function is also closed interval minus 1 to 1. And here y equal to fx, that means y equals sin x. In that case we get x equals sine inverse of y. That means this will be belonging to closed interval minus 1 to 1. Also in the question, codomain is closed interval minus 1 to 1. Since range and codomain are equal, therefore this function is onto. Hence we are done. To check whether the functions are onto or not, we have only 3 questions, 1, 2 and 3. So we are done here. Now the last question of today's session is question number 5. Prove that the function f from set of real numbers to set of real numbers defined as f of x equal f of x equal 5x cube minus 8 is bijective. So we have to show that this function f is bijective, and bijective is nothing but both 1 1 and onto. Bijective means the function is both 1 1 and onto. That means both surjective and injective. Then it will be called as bijective map. We are given f of x equal 5x cube minus 8. To show onto, let us take two elements, x1 and x2 belongs to the domain R. Then taking f of x1 equal f of x2, we will have 5x1 cube minus 8 equal 5x2 cube minus 8. Now cancelling on both sides, we finally get x1 cube equal x2 cube. Now we write x1 cube minus x2 cube equal 0. Now it is in the form of a cube minus b cube. Therefore, we expand x1 minus x2. Whenever a cube minus b cube, we will get the expression as a minus b into a square plus ab plus b square. So here it will be right. The expression x1 cube minus x2 cube can be written as this. Now either this equals 0 or this part equals 0. Either x1 minus x2 equals 0 or x1 square plus x1 into x2 plus x2 square equals 0. This implies obviously x1 equal x2. But is the expression x1 square plus x1 into x2 plus x2 square can be 0? Obviously not, because here all the terms are positive. Since we know that the term x1 square, this is a square term, and also x2 square, that means x1 square plus x2 square is obviously greater than equal 0, and plus x1 into x2 as a whole, this expression cannot be 0, so this is not possible. This is not possible. Therefore, we finally get x1 equal x2 whenever we have taken that f of x1 equal f of x2. For f of x1 equal f of x2, we get x1 equal x2. Therefore, the function f is 1, 1. Now to check onto. Let y equal f of x. That means y equal 5x cubed minus 8. We express x in terms of y. 5x cubed equal y plus 8. X cubed will be equal to y plus 8 divided by 5. Now we require x only. Therefore, x equal cube root of y plus 8 by 5. For any y belongs to real number, x equal to cube root of y plus 8 divided by 5 is obviously belongs to a real number. Therefore, here codomain and range are equal. Hence, the function f is onto also. Since the function f is 1, 1 and onto, therefore we get f as bijective map. Since f is both surjective and injective, therefore we can say that f from R to R defined as f of x equal 5x cubed minus 8 is a bijective function. Hence, this question is also done. I hope you are all understanding this. So, this is the session regarding this type of problems on functions. So, that's all about this session. So, if you like my video, then do subscribe to my channel. That's all. Thank you.